Hey there, so our last lesson of the week is to talk about derivatives of logarithmic functions. So the derivatives of logarithmic functions, as maybe you'd guess, are not super complicated because e to the x, if you remember, we had the connection between ln of x and e to the x. They're not super complicated, but they are also weird. Like they don't follow necessarily a logical pattern. The way, if you remember, the derivative of e to the x was just e to the x. The derivative of ln of x, the natural log, is 1 over x. This is definitely one of those ones you just want to memorize. If you have a different base, so remember ln is a log base e, but if you have any number other than e right here, it's going to be similar, but it's going to be 1 over x times ln of a. And one thing that's really important to remember here is that the ln of a, this is a constant. So you can type it into your calculator. It might be 7, if it's log base 7, anything like that. All the same rules apply. It's just here's another nice set that you've got here. So if I have here the derivative of ln of third root, cube root of x, you have two different options here. You can either use the chain rule, which is going to say that your outer function is natural log. So then f prime, using this new formula, is 1 over. So in this case, right, whatever's in here, down here. G, I would rewrite as, we have the cube root, which I would write as x to the 1/3. Using the power rule, that's 1/3 x to the negative 2/3. Now, the other option is that you maybe just remember your log rules. And this is going to be a really helpful thing to think about, is that if you have your log rules, this is ln of x to the 1/3, as we've just said right here. And maybe you remember that that means this can jump in front and just turn into a nice constant, ln of x. Now, either way, you will get the same answer, but if you remember your log rules and can use them well, this homework assignment is just going to go a lot easier because, as you imagine, there's a lot of logs in here. You won't always be able to use them, but the nice thing, as I said, is you'll get the right answer. If you're using the chain rule, then the derivative, so dy dx, is going to equal 1 over x to the 1/3 times 1/3 x to the negative 2/3. Right, because we take this, we plug in g, and we multiply by g prime. When I simplify this, get 1 over x to the 1/3 times 3, which is this 3, and then this will drop into the denominator as well. So x to the positive 2/3. Our x terms can combine 1/3 with 2/3. We get 1 over 3x. Again, this is also what would happen here, since the derivative using this method would be 1/3 times the derivative of the natural log, 1 over x, which is 1 over 3x. You'll just notice a little bit easier if I remember my log rules. Number 2 asks, find y prime and y double prime, so the first and second derivative of y equals log base 2 of x. So the first one is we have our different base here than ln. So this just means that a is equal to 2. So using our formula from before, we can say y prime is equal to 1 over x times the ln of 2. That's just using our formula. Now, to take the derivative again, I would rewrite this by pulling out the constant times 1 over x, since remember that's a constant. And then I would rewrite 1 over x as x to the negative 1. So then I can use my power rule here, And then the constant multiplier just comes straight down. So y double prime is equal to 1 over ln of 2 times negative 1x to the negative 2. And I would then simplify. Negative 1 in the numerator, x squared drops into the denominator, and we still have an ln of 2 for our second derivative. And there's our first. If you have questions about anything from this week, please make sure that you're nominating questions in the homework question form so I can see who's stuck on what. I can post videos if that's going to be helpful. And you can also leave me questions in the comments, set up a Zoom call, or by email.